Now what I want to talk about is opportunity costs with this curve here, this example. And as I mentioned, the opportunity cost for a production possibilities curve is a lot different than the budget line, because with the budget line, the opportunity costs were constant. It was just the slope of the line. Versus here, the opportunity costs are always changing from one point to the next, hence why we get that curve shape. And so we can analyze this curve in two different ways. We can go down the curve or we can go up the curve. So I'm going to analyze it both ways, but I'm going to start with going down the curve. And if we're going down the curve for this specific example, what is happening? Notice if we're going down the curve, so from point A to B to C to D to E to F, notice that the number of SUVs is increasing and then the number of cars is decreasing. And so as we go down the curve, what's happening is we're producing more SUVs. And to produce more SUVs, because we have limited resources, we can make less sports cars. And so let's get into a little bit more detail. Let's go from point A to point B. What's happening here? Well, notice that to make 20 extra SUVs, right, to go from here to here, 0 to 20, we have to sacrifice making 2 sports cars. And so more specifically, what this means here is that the opportunity cost for 20 SUVs is 2 sports cars. The opportunity cost of producing 20 more SUVs, we have to sacrifice producing 2 sports cars. Okay, and notice that we could simplify this ratio here. So this could simplify to plus 10 SUVs. We sacrifice 1 car. Right? Plus 20 over negative 2 is the same as plus 10 over negative 1. So the opportunity cost of producing 10 SUVs is 1 car. Both of those mean the same thing. Now, lots of times what they're going to want is they're actually going to want the opportunity cost in terms of 1 unit that you're producing. So from point A to B, what is the opportunity cost of producing 1 SUV? So this is an example of a question that you can easily get on your midterm or exam, given data like this. And I've mentioned this in the budget line as well. What you want to do is you want to take this ratio here. So we got plus 20 SUVs minus 2 cars. And you basically want to take this ratio and make it equal. If you're finding the opportunity cost of producing 1 SUV, you want to put a plus 1 here. But then what you're going to have to do is you're going to have to solve for this X value here. To produce 1 SUV, what's the opportunity? How many cars do we have to give up in producing? And so to solve for this X value, you just cross multiply. So X times positive 20 is 20X. And then negative 2 times positive 1 is negative 2. You can kind of erase these words here if you could see that better then. And then X would equal negative 2 over 20. We would divide both sides by 20 to isolate for that X. And this here would simplify to negative 1 over 10. Or if you want it in decimals, negative 1 over 10 is the same as negative 0.1. Okay, so what is the opportunity cost of producing 1 SUV? The answer to this is 1/10 of a car, or 0.1 of a car. So you got to be comfortable in knowing this fraction or knowing this decimal, right? The multiple choice answers could be one of those. Sometimes they'll be fractions, sometimes they'll be decimals. So you got to be able to get both, be comfortable in getting both. Another thing is that you got to be comfortable in this number changing. So sometimes they'll ask, what is the opportunity not of producing one SUV? Sometimes they might bring in another different number. They might say, what's the opportunity cost of producing 5 SUVs? So then this number here would change to a 5. And you'd have to solve for x then. And when you solve for x then, you'd have 20x equals -10. So x would be -10 over 20 or -1 over 2. So the opportunity cost of producing 5 SUVs is sacrificing half, producing half of a car, or 0.5 of a car. Okay, so just be comfortable in getting fractions or decimals and this number changing. You'd have to use the ratio from the table and then cross multiply. So any of these types of questions can come up. And these numbers here are going to change from as we move down the curve from one point to the next. So we can actually make a table of all of this. Let me show you here. Right, so with a line it was constant, but again with a curve it matters what point to which point. So again, we're going down the curve, and then let's make a column for a general trade-off, which is what we're going to get from the graph or the table. And then let's make a column for opportunity costs of producing one SUV. Okay, so moving down the curve, if we're going from A to B, we mentioned how to get 20 SUVs, we have to sacrifice what? 2 cars? And with that cross multiplying we did, we found out that the opportunity cost of producing one extra SUV, we have to give up what? 1/10 of a car, or -0.1 of a car. I'll just keep it in decimals. Right? So the opportunity cost of one SUV as we're moving from point A to B is 1/10 of a car, or 0.1 of a car. But now this number is going to change as we go from B to C. Notice as we go from here to here, what's going to happen is to produce 20 SUVs, we have to produce 4 less cars. Right? So the opportunity cost of producing 20 SUVs is 4 cars. But if we want it in terms of one SUV, what we would do, 20 over -4 equals, we want this to be 1, we would solve for that x value there. Cross multiply, 20x equals -4, so x would be -4 over 20. If you simplify this, this would be -1 over 5, or -0.2. So the opportunity cost as we move from B to C of producing one extra SUV is we have to sacrifice 1/5 of a car. Here it was 1/10, here it's 1/5. Or in decimals, we got to sacrifice 0.2 of a car. Right? So notice that that opportunity cost is changing. It is different as we move from B to C. Right? So that's why that production possibilities curve, sometimes there's a little bit more work involved in analyzing it versus analyzing a budget line, because this was always constant. And again, it might sound like a parrot here, mentioning the same thing over and over, but just to really drive this point home is you got to be able to know what the opportunity costs for whatever number of SUVs they're asking for. So again, you might get a question, as we move from B to C, what's the opportunity cost of producing 7 SUVs? And you got to be able to solve for that value right there. So we'd have 20x equals -28. So x would be negative 28 over 20, which would be, what, negative 7 over 5? So the opportunity cost of producing 7 SUVs is 7/5 of a car, and in decimals, this would be negative 1.4. So the opportunity cost of producing 7 SUVs is 1.4 cars in this interval here as we move from B to C. So again, you got to be comfortable in answering any of these types of questions. And if you fill in the rest of the table with this data here, you'd end up getting this. So from C to D, D to E, E to F. And more specifically, what I want you to notice is how the opportunity costs are changing for that one SUV in each point. And not only are they changing, they're not constant. Notice that they're increasing. So over here, the opportunity cost of one SUV is 0.1 cars. But here it's 0.2 cars for that same one SUV. And then for one SUV here, it's 0.4 cars, 0.8, and then one full car. Right? So not only are they not constant, but the opportunity costs are increasing. And there's actually a law for that called law of increasing opportunity costs. And the intuition behind it is that, let's say that we're going from point A to B. What's going to happen is, let's say that in your car manufacturing company, there's 2 departments, one SUV department and then one sports cars department. Well, as we go from here to here, maybe what's going to happen is you have to shift some workers from the car department to the SUV department. So let's say that you shift 5 workers to go from here to here. But then what's going to happen is to go from B to C to produce another 20 SUVs, you're going to have to shift 5 more workers from the car department to the SUV department. And now you're going to have 10 workers in total. And let's say that 10 workers can't manage themselves when there's 10 workers. If there's 5 workers, they can manage themselves. But if there's 10, then there has to be some kind of management. There has to be some kind of supervision. So in addition to these 5 workers, now you have to also transfer a manager to that department to look after these 10 workers. And up here, you didn't have to. And then maybe as you move down here, you may not even have any more of these workers to transfer. So now what you got to transfer is even higher quality resources like machines. So let's say you have to now to go from, this was A to B, B to C. So to go from C to D, now you got to transfer, let's say like 2 machines. And then you have to transfer 2 specialized workers, more specialized workers in order to run these machines. And let's say these machines are capable of producing more sports cars than these workers are, hence why that opportunity cost is going up. And so what happens is as you move down and down the possibilities, as you move down the curve, you have to use higher and higher quality resources. And so that's how I like to personally think about the law of increasing opportunity costs. So more specifically, for every new unit produced, higher quality resources have to be used. You may see different definitions for this law of opportunity costs, but that's kind of how I like to think about it, right? For every new unit produced, higher quality resources are used. Hence why that opportunity cost as you move down the curve is increasing. Now, what if we go the opposite way? What if we go up the curve this way? Well, if we're going up the curve, notice how there's going to be less SUVs produced if we're going this way. Right? We're going to be going to the left on the x-axis, but we're going to be going up on the y-axis. So going up the curve, we're going to have more cars and less SUVs. So we can make this same table, but going up the curve. And it's not going to be an opportunity cost now of producing one extra SUV. It's going to be the opportunity cost of producing one car. And again, this number can be anything, but I'm just using 1 for now just to show you how we go from this general trade-off to this 1 unit, but it could be whatever number of units. So if we're going up the curve, the starting point would be from F. The first interval is going from F to E. So if we're going from F to E, notice that we're making 20 cars. And to make 20 cars, we have to sacrifice making 20 SUVs. So the opportunity cost of producing 20 cars is 20 SUVs. And this actually reduces nicely to, if we want to make one extra car, we got to sacrifice one SUV. Right? So that's the opportunity cost of one car, producing one extra car, if we're in this interval going from F to E. But if we go from E to D, this is all going to change. So notice that from E to D, to produce 16 cars from 20 to 36, what's the opportunity cost of producing 16 cars? It's going to be sacrificing 20 SUVs. So even though this number stayed the same, the denominator is staying the same, the numerator is changing. Hence, that overall ratio is changing. The overall opportunity cost is changing. And we got 16 cars. To make 16 cars, we got to sacrifice 20 SUVs. Well, if we want the opportunity cost in terms of one car, we got to solve for this x value here. And so we would have 16x equals negative 20. So x would be negative 20 over 16, which would be negative 5 over 4, or negative 1.25. So here, to make one extra car, the opportunity cost of one car is going to be 1.25 SUVs, right? So the opportunity cost is different, and not just different, notice how it increased. Here was one SUV, now we got to sacrifice 1.25 SUVs, or 5/4 of an SUV. Remember, some multiple choice questions may be in fractions, so make sure you're comfortable with these fractions as well. And some multiple choice questions won't be asking for the opportunity cost of one car. They'll say from point E to D, what's the opportunity cost of, let's say, 3 cars. And then you got to solve for this x value here. So then you would have 16x equals negative 60. So x would be negative 60 over 16. Simplifying this, we would get negative 15 over 4. That can't simplify further, so a multiple choice answer might be that. So the opportunity cost of 3 cars in this interval is 15/4 of an SUV. Or it might be in decimals, so 15/4 is what? 3.75? 3.75 SUVs. So a multiple choice question can have either of these answers, right? So make sure you're comfortable in getting either. And if we fill the rest of this table out for the up curve, we end up getting these values here. And notice in blue, I have the opportunity costs for each of these intervals circled. And again, notice that not only is the opportunity cost not constant, it is changing, but it's also increasing, like it was when we were going down the curve. So the opportunity cost of one car is 1 SUV, but down here it's 10 SUVs. And again, it's that same law of increasing opportunity costs. Basically, as we produce more of one unit, higher quality resources have to be used as we move up the curve or the other way down the curve.